Hello friends, I am Chandan. Today's topic is radiation. This is very important topic for gate from point of view. So this is very important topic. Okay, if you want to get mechanical handwritten notes, then you may go Telegram group, that is Mechanical Bengali. Mechanical Bengali. Here all handwritten notes which is available in this group, you can go there and download the handwritten notes. Okay, so first uh, so f- in radiation, first question, that is question number 1. Question number 1, read the question. For a glass plate, transmissivity and reflectivity are specified as 0.86 and 0.08 respectively. The absorptivity of the glass plate. So what is given in this question? So question number 1. Question number 1. So for a glass plate, transmissibility is given and reflectivity is given. Transmissibility, that is equal to 0.86, and reflectivity that is equal to 0.08. So you have to find out what is the absorptivity, alpha. So the formula is absorptivity plus reflectivity plus transmissivity, that is equal to 1. So from here, alpha plus rho, that is 0.08 plus 0.86, that is equal to 1. From here, alpha, that is equal to 0.06. So this is the correct answer, 0.06. So option D, 0.06. This is the correct option. Okay, now question number 3. Okay, read the question carefully. So in question number 3, the radiative heat transfer rate per unit area, that is watt per meter square, between two plane parallel gray surfaces, emissivity, that is equal to 0.9, maintained at 400 Kelvin and 300 Kelvin each, and Stefan Boltzmann constant, that is equal to 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. So what is given in this question? Question number 3. So here two plate is given. There is two plate number 1 and plate number 2. Okay, so the radiative heat transfer rate per unit area, you have to find out the radiative heat transfer rate per unit area, watt per meter square is equal to what. Okay, what is given in this question? So emissivity of two plates, that means emissivity epsilon 1, that is equal to epsilon 2, that is equal to 0.9, and temperature T1, this plate temperature, that is 400 Kelvin, and T2, that is 300 Kelvin. Okay, and sigma, what is the value of sigma? 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. So you have to find out Q dot by A. So the formula of Q dot by A, that is equal to sigma T1 to the power 4 minus T2 to the power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. From here, what is the value of sigma? 5.67 into 10 to the power minus 8 T1 to the power 4, 400 to the power 4 minus 300 to the power 4 by 1 by epsilon 1, that is 0.9 plus 1 by 0.9 minus 1. From here you can get the value, that is 811.84 watt per meter square. So this is the correct answer. So the correct answer is 812, option B. Option B is the correct answer. Now question number 5. This is very important question. This is very very important question. Read the question carefully. Read the question carefully. So for the circular tube of equal length and diameter shown in the figure below. So this is a circular tube of equal length, the length that is equal to diameter, and this is the diameter. Okay, the view factor f13 that is equal to 0.17. The view factor f12 in the case will be, we have to find out the view factor of f12. So first you have to know what is view factor. View factor means it is the fraction of energy radiating from one surface and strike the other surface directly without considering any intermediate reflection. So this is the view factor. That means fraction of energy radiating from one surface and strikes the other surface. So this is the view factor. This is very very important for GATE. Okay. So first of all, what is given in this question? What is given in this question? So question number 5. Question number 5. So there is a circular tube is given. There is a circular tube is given. Circular tube is given. This is the cross section here, and this is also the cross section here. This surface is surface 1. This is surface 2. This surface, the cylindrical surface. This is surface 2, and this flat surface, this is surface 3. Okay, and this is the length here, and this is the diameter. Okay, this is the diameter. Okay, now what is given? The view factor f13 is, so the given concept is f13 that is equal to 0.17. The view factor f12, you have to find out the view factor f12. How you find out this value? Okay, so f13, the fraction of energy from plate 1 to plate 3 is given, that is 0.17. Then fraction of energy from plate 1 to plate 2 is what? Fraction of energy from plate 1 to plate 2 is what? Okay, so this is the formula is f11, view vector of 11, f12 plus f13 that is equal to 1. So f11 that is equal to 0, because this is a flat plate, that's why view factor that is equal to 0, plus f12 you have to find out this, and f13 that is 0.17 that is equal to 1. From here f12 that is equal to 0.83. So this is the correct answer. 0.83 is the correct answer. Okay, so here option D, that is 0.83. This is the correct answer. Okay, now next question, read the question carefully. Question number 6. Here what is the value of the view factor for two inclined flat plates having common edge of equal length and with an angle of 20 degrees? Okay, so you have to find out the view factor for two inclined flat plates. You have to find out the view factor of two inclined flat plates. Okay, so try to understand this question. This is important question also. Question number 6. Here question number 6. So suppose what is given in this question. So here this is two plate. Okay, this is one plate and this is another plate. This is one plate, this is plate number 1, this is 1, and this is 2. The length of this plate, this is L, Okay, the length of this plate, that is L. Okay, and this is also L. The length of this plate is also L. Okay, now this angle is 20 degree. This angle is 20 degree, and you have to find out what is the value of, you have to find out what is the value of F12. What is the value of F12? 1 to 2. So suppose you have to consider, you have to connect this line, you have to connect these 2 points. Okay, so this 2 point, suppose the length of this 2 point, that is equal to B. Okay, the length of this 2 point, that is equal to B, and this is the, here this angle, this is total 20 degree, and then this is, that's why this is 10 degree, and this is also 10 degree, and this is 90 degree, and this is 80 degree, this is 80 degree, and this is 90 degree. Okay, this is 90 degree. Now so you can say that this is the V vector concept. Okay, F11 plus F12 plus F13, that is equal to 1. What is the value of F11? That is equal to 0. This is the plate, that's why this is the plate, this is the plate, that's why F11, that is equal to 0. Plus you have to find out F12 plus what is the value of F13? The fraction of heat which is transferred by radiation from 1 to 3, that is F13. Okay, so what is F13? How to calculate this F13? This is very, very important. Suppose this is the, we have to apply reciprocity theorem. Okay, we have to apply, so applying APPLYING, applying reciprocity theorem. Okay, so here if you apply reciprocity A1 F1 3 between apply reciprocity theorem between 1 and 3. So we have to apply reciprocity theorem between plate 1 to plate, suppose this is plate 3, this is plate 3, this is plate 3, this is plate 3. We have to apply reciprocity theorem. So A1 F13, that is equal to A3 F31, A3 F31. So what is the A? What is the A1? What is the A1? Suppose the width of this plate is W. Suppose this width of the plate is W. So here the L into W into F13, that is equal to, what is the value of B? What is the value of B? That is, what is the value of B? So this is theta. So what is the value of D? This is, so here this length will be L sin theta, sin 10 degree, and this length will be, because this length will be L sin 10 degree. So total B, so you can say that B, that is equal to L sin 10 degree plus L sin 10 degree, that is equal to 2L sin 10 degree. Okay, so here what is the value of A3? A3 means B into W. W is the width of this plate. Okay, so 2L sin 10 degree into W into F31. F31, what is the value of F31? 3 to 1. So fraction of heat which is transferred from 3 to 1. So there is a 2 plate, and so the angle here, this is 80 degree and this is 80 degree. So that's why the F31 will be 0.5. F31 will be 0.5. F31 that is equal to 0.5. So 0.5 because F31 that is equal to 0.5. So from here F13 this is LW cancel out and F13 is equal to 0.17. So from here this is F13 0.17 that is equal to 1. So from here F12 that is equal to 0.83. So 0.83 is the correct answer. So here the correct answer is 0.83. Okay, option A is the correct answer. Now next question number 7. Read the question carefully. So question number 7. A plate having 10 cm square area, each side is hanging in the middle of a room of 100 meter square total surface area. The plate temperature and emissivity are respectively that is 800 Kelvin and 0.6. The temperature and emissivity values for the surface of the room are 300 Kelvin and 0.3 respectively. The Boltzmann constant 5.67 into 10 to the minus 8 watt per meter square Kelvin to the power 4. The total heat loss from the two surface of the plate is what? From the two surface of the plate. The total heat loss from the two surface of the plate is what? So what is given in this question? Question number 7. Question number 7. So here a plate having so area A1 that is equal to 10 centimeter square. Each side is hanging in a middle of a room. So A2 area that is 100 meters square. Okay, suppose this is one room. Okay, this is one room. Okay, this is one room. Okay, so a plate is hanging from the top floor. The area of this plate is 10 centimeter square and the area of this room that is 100 meter square. Okay, so this is 1, this is 1, this is 1 and outside surface that is 2. The plate temperature and emissivity are respectively. So plate temperature, this plate inside this plate temperature that is equal to 800 Kelvin and emissivity that is 0.6. The temperature and emissivity values for the surface of the room. So T2 that is equal to 300 Kelvin and emissivity epsilon 2 that is 0.3. Okay, sigma, what is the value of sigma? Boltzmann constant that is sigma that is equal to 5.67 into 10 to the power minus 6 watt per meter square Kelvin to the power 4. The total heat, so the total heat transfer, so total heat loss, you have to find out the total heat loss from two surface of the plate to 2 q dot. Okay, so how you calculate this q dot? You know the formula, that is q dot that is equal to sigma into T1 to the power 4 minus T2 to the power 4 by 1 minus epsilon 1 by epsilon 1 A1 plus 1 by A1 F12 plus 1 minus epsilon 2 A2. So this is very important formula. This is very important formula. Okay, so from here q dot that is equal to sigma. What is the value of sigma? 5.67 into 10 to the power minus 6 into T1 to the power 4, that is 800 to the power 4 minus T2, that is 300 to the power 4 by 1 minus epsilon 1. What is the value of epsilon 1? 0.6 by epsilon 1, 0.6 into A1. A1 is value, that is, what is the value of A1? That is 10 into 10 to the power minus 4 meter square, that is 10 to the power minus 3 meter square, 10 to the minus 3 meter square. From here, this is 10 to the power minus 3 plus 1 by A1, that is 10 to the power minus 3 into F12, that means the fraction of heat which is transferred from this to this will be 1, because this is the flat surface. So that's why F12, that is will be 1 plus 1 minus epsilon 2. What is the value of epsilon 2? That is 0.3. 0.3 by epsilon 3, that is 0.3 into A2. A2 means 100 meter square. 100 meter square. From here, Q dot that is equal to 13.65. 13.65 watt. So that means total heat loss, that is equal to 2 Q dot, that is to 2 into 13.65 watt, that is equal to 27.32 watt. So this is the correct answer. So the correct answer is option B, that is 27.32 watt. Okay, next question number 9. Read the question carefully. Question number 9. A solid cylinder surface 2 is located at the center of a hollow sphere surface 1. The diameter of the sphere is 1 meter, while the cylinder has a diameter and length that is 0.5 meter each. The radiation configuration factor F11 is. You have to find out the F11. Okay, so what is given in this question? Question number 9. What is given? So a solid cylinder surface 2 is located at a center of hollow sphere. So here this is the hollow sphere. This is 1, and there is a solid cylinder. In this hollow sphere, inside the hollow sphere there is a solid cylinder. Okay, solid cylinder. Okay, the diameter of the sphere. What is the diameter? Diameter of the sphere, that is equal to 1 meter, and this is 1 and this is 2. This surface is 1 and the solid cylinder surface, that is 2. The diameter of the sphere, that is 1 meter, while the cylinder has a diameter and length is equal to 0.5 meter each. So this is the length. This is the length of this cylinder, and this is the diameter of this cylinder. Okay, so length, that is equal to diameter, that is equal to 0.5 meter. And from here, this is the diameter of this sphere. From here, radius of this sphere, that is 0.5 meter. Okay, so the radiation configuration factor F11, you have to find out the value of F11 equal to what. That means heat is transfer, the fraction of heat which is transfer from surface 1 to surface 1, that is equal to what. Okay, so how you calculate this value? Then there is a view vector concept, that is F11 plus F12, that is equal to 1. From here, F11, that is equal to 1 minus F12. Here apply reciprocity theorem. So applying APB, for finding out F12, you have to apply reciprocity theory. Applying reciprocity theorem. So here A1 F12 that is equal to A2 F21. From here F12 that is A2 by A1 F21. From here F12 that is equal to A2. What is the value of A2? Area of this cylinder. What is the area of this cylinder? So pi by 4 d square, this area, pi by 4 d square plus pi by 4 d square plus pi dl, this area, pi dl. So here 2 into this 2 area, pi by 4 d square, 2 into pi by 4 into d square. What is the value of d? That is 0.5 square plus pi dl, pi into d into l, d and l value is same, 0.5, so 0.5 square by a1. What is the value of a1? That is 4 pi r square. 4 into pi. What is the value of r for sphere? That is 0.5. That is 0.5 to the power square. And what is the value of F21? The fraction of heat energy which is transferred from 2 to 1 surface. That is equal to 1, because this is the flat surface, and this is the cylinder. So heat is transferred from this plate to this plate will be 1. The fraction of heat transfer, that is equal to 1. So this is equal to 1. So what is the F21? That is equal to 1. So if you calculate that value, F12 will be 3 by 8. Okay, this value will be 3 by 8. F12 value will be 3 by 8. So from here, if you put this value from this equation, F12 that is to 1 minus 3 by 8. So from here F11 that is equal to 0.625. So this is the correct answer. So 0.625 is the correct answer here. So in this question there is a 0.625 is the correct answer. Okay. So the next question number 10. Question number 10. Read the question carefully. Question number 10. Question number 10. A 100 watt electric bulb has switched on in a 2.5 meter into 3 meter into 3 meter size thermally insulated room having a temperature of 20 degrees Celsius. The room temperature at the end of 24 hours will be. What is the room temperature? Room temperature. You have to find out the room temperature at the end of 24 hours will be. Okay. So what is given in this question? So question number 10. What is given? So question number 10. So heat transfer rate Q dot that is equal to 100 watt. Electric bulb has switched on. So what is the volume of this room? That is 2.5 meter. 2.5 into 3 meter cube. Thermally insulated room having a temperature. So initial temperature that is T1 that is equal to 20 degrees Celsius. Okay. So after 24 hours, what is the final temperature? T2 equal to what? After 24 hours. After 24 hours. So how we calculate this value T2? How we calculate the value of T2? Okay. How we calculate? So the total heat. So from here you can see that the heat transfer rate is equal to 100 watt. That means that is 100 joule per second. So the total heat transfer. So total heat transfer that is equal to 100 joule per second. 100 into 24 hours. 24 into 3600, because 1 hour is equal to 3600 second. So the total heat transfer. So this will be joule. The total heat this will be joule. The heat transfer by electric bulb. The heat transfer by electric bulb. This is Q. Okay. Now heat is gained by air inside the room. That is Q. That is equal to mCp delta T. that is m Cv, that is T2 minus T1. So now at m, what is the value of m? M, we know that rho equal to m by v. So from here m equal to rho into v. So what is the value of rho? The density of air, that is equal to 1.2. Air density, that is equal to 1.2 kg per meter cube. Okay, 1.2. What is the volume? That is 2.5 into 2.5 into 3 into 3. So here 1.2 into 2.5 into 3 into 3. What is the value of Cv? That is 717. The Cv value, that is equal to 0.717 kilojoule per kg Kelvin. From here 717 joule per kg Kelvin. So from here this is 717 into T2. You have to find out this value T2 minus T1. T1, that is 20 degree. So heat supply by the so you can say that from here you can say that heat supply by the electric bulb is equal to heat gain by air inside the room. So this is equal to, so 1.2 heat gain into 2.5 into 3 into 3 into 717 into T2 minus 20 degree, that is equal to 100 into 24 into 3600. From here you can calculate the value of T2, that is equal to 466 point something, 466 degrees Celsius. That is almost equal to 470 degrees Celsius. So 470 degrees Celsius is the correct answer. So here option D, that is 470 degrees Celsius. This is actual answer is 466 point something, but here the option is 470. This is near about, that is 470. So the correct answer is option D, 470. Now next question, that is question number 11. Question number 11. So read the question carefully. So question number 11, read the question carefully. So what is the question? So a hollow enclosure is formed between two infinitely long concentric cylinders of radius 1 meter and 2 meter. So this is the cylinder here. The inside cylinder, that is 1 meter, and the outside cylinder radius, that is 2 meter respectively. Radiative heat exchange takes place between the inner surface of the larger cylinder, surface 2, and the outer surface of the smaller cylinder, surface 1. The radiating surfaces are diffuse and the medium in the enclosure is non-participating. The fraction of thermal radiation leaving the larger surface and striking itself is. Okay, so what is given in this question? So question number 11 here, this is the cylinder here, this is the small cylinder and this is the large cylinder. Okay, this is the large cylinder. Okay, the small cylinder radius, so suppose this is 2, small cylinder, large cylinder is 2 and small cylinder is 1. Okay, small cylinder is 1. Okay, now the radius of small cylinder, that is equal to 1, radius of small cylinder, that is equal to 1, and radius of large cylinder, that is equal to 2. So you have to find out the fraction of thermal radiation leaving the large cylinder and striking itself. So the fraction of thermal radiation, so the fraction of thermal energy from 2 to itself, from this surface to itself, that means F22. You have to find out the value of F22. So how you find out this value F22? You have to find out this value of F22. So here you know the formula for V vector. From V vector you know the formula F22 plus F21, that is equal to 1. That means fraction of heat which is transferred from 2 to 2 and fraction of heat which is transferred from 2 to 1 will be equal to 1. That means this is the very very important formula. Okay, so from here F22 that is equal to 1 minus F21. So how you find out this value F21? So if you want to find out the value of F21, so you have to apply reciprocity theory. So applying reciprocity theorem. Okay, so if A2 F21 that is equal to A1 F12. From here F21 that is to A1 by A2 F12. From here F21 that is to what is the value of A1? What is the value of A1? That is the surface area of this cylinder, that is pi r into L, 2 pi r into L. Sorry, the surface area of this cylinder, that is 2 pi r into L or pi d into L. So 2 pi r into L. L means length of the cylinder. So 2 into pi into R1 that is 1, 2 pi r into L, the length is suppose L, 2 pi r L by, for surface 2 the area of the surface 2 that is 2 into pi into r. What is the value of r? That is 2 into L. And what is the value of F12? The fraction of heat which is transferred from 1 to 2 by radiation is equal to 1, because this is the cylindrical surface. That's why F12 that is equal to 1. So if you calculate that value, then F21 is equal to 0.5. From here F22 that is equal to 1 minus, so if you put this value here, that is 0.5. So from here F22 that is equal to 0.5. So this is the correct answer. 0.5. So the correct answer is option B, 0.5. Now next question, that is question number 15. Read the question carefully. Question number 15. Question number 15. Read the question carefully. Okay. So consider two infinitely long thin concentric tube of circular cross section as shown in the figure. If D1 and D2 are the diameter of inner and outer tubes respectively. So this is the inner tube and this is the outer tube. Okay, the D1 is the inner tube diameter and D2 is the outer tube diameter respectively. Then the view factor F22 is given by. This is same question, previous same question. Okay, so what is given in this question? There is a two surface. This is the long concentric tubes, that is long concentric cylinder. Okay, this is surface 1 and this is surface 2. Okay, this is surface 1, this is surface 2. The diameter, so here the diameter, this is D1, and the larger diameter, this is D2. So you have to find out what is the value of F22. Okay, F22. So how you calculate this value F22? You have to find out this F22 value. So how you calculate this value F22? So F22 means, if we know the formula from view factor F22 plus F21 that is equal to 1. From here F22 that is equal to 1 minus F21. From here F22 that is equal to, what is F21? What is the value of F221? That is, if you apply reciprocity theorem, applying reciprocity theorem, then A2 F21 that is equal to A2 F21 that is equal to A1 F12. From here F21 that is A1 by A2 into F12. F21 that is equal to, what is A1? A1 that is pi d into L. Pi d that is d1 into L, length of this cylinder, that is L. Okay, if you consider the length of this cylinder, that is L, by pi d, the A2 that is pi d 2 into L into, what is the value of F12? F12 will be 1, because fraction of heat which is transfer from 1 to 2 will be 1, because there is a cylindrical surface. That's why F12 that is equal to 1. So from here F21 that is equal to d1 by d2. So from here, so F22 that is equal to 1 minus F21. So 1 minus F21 that is d1 by d2. So this is the correct answer. So the correct answer is option D, that is 1 minus d1 by d2. Now next question, and this is the last question of this day. Okay, so what is given in this question? So question number 16, two large diffused gray parallel plates separated by a small distance have surface temperature of 400 Kelvin and 300 Kelvin. If the emissivities of the surfaces are 0.8 and the Stephen Boltzmann constant is 5.67 into 10 to the power minus 8 watt per, this is meter square, Kelvin to the power 4, the net radiation heat exchange rate in kilowatt per meter square between the two plates. You have to find out the net radiation heat exchange rate in kilowatt per meter square between the two plates. So first of all, what is given in this question? You have to find out what is given in this question. So in this question, what is given? There is a two plate, gray plate is there. This is one plate and this is number 2 plate. Okay, this is gray plate separated by a small distance, have a surface temperature. So suppose T1 that is 400 Kelvin and T2 that is 300 Kelvin. If the emissivity of the surfaces are 0.8, so emissivity of both surfaces are same. Then epsilon 1 that is equal to epsilon 2 that is equal to 0.8. The Stephen Boltzmann constant sigma that is equal to 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. Okay, so the net radiation heat exchange rate, so Q dot by A that is equal to what? In kilowatt per meter square. So you have to find out this Q dot by A. So what is the formula for finding Q dot by A? What is the formula for finding Q dot by A? So Q dot by A that is equal to sigma T1 to the power 4 minus T2 to the power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. From here that is equal to, so what is the value of sigma? That is 5.67 into 10 to the power minus 8 into T1 to the power 4 that is 400 to the power 4 minus 300 to the power 4, T2 to the power 4 by 1 by epsilon 1 that is 0.8 plus 1 by epsilon 2 that is 0.8 minus 1. If you calculate this value will be 661 watt per meter square, that is equal to 0.661 kilowatt per meter square. So the correct answer is 0.661. So this is the correct answer. So from here, so in question number 16, the correct answer that is 0.66. So option A is the correct answer. Okay, so thank you everyone. Thank you.